Welcome to Altair Engineering Training and Support. In this video, I am going to show you how to create or how to generate 3D mesh and perform a static analysis on knuckle. So this is for this knuckle, I am going to apply forces in 3 axes on the this portion with the 3G forces in 2 direction and a lateral 1G force in the lateral axis, plus I'm going to apply torque at the 2 locations of 1G loading torque we are going to apply, and rest the area we are going to constrain for the 3 degrees of freedom. We'll follow the same process as we have done in earlier process, that is MPCLL, where we create a material as steel, create properties for 3D element, giving the piece solid as the card image, then update the component with proper properties, and this time we are going to apply the load collectors for force, torque and constraint, and lastly we'll define the type of analysis by defining the load step. So now I'll show you how to process that. So open Hypermesh. Once you open Hypermesh, from the preferences pull down menu, select the user profile as radius bulk data. Make sure the user profile is radius bulk data because you are performing static analysis. Then click on OK, that it will load the radius bulk data user profile. Then after that, once it's loaded, on the top also you have to cross check it again that whether it is showing radius bulk data or not. So make sure it is showing the radius bulk data format at the top also. Now click on open folder to open the Hypermesh file which you have edited and saved during the addition of the 3D mesh, or if you have the CAD model you can directly import that CAD model also by import geometry. So as I have HM file saved, so I will open that HM file. So in this way you can see my knuckle geometry has been imported. Now I will process first with the geometry check whether the geometry is perfectly enclosed volume or not. If it's not, then we can edit that and then we can proceed it for the 3D mesh. So I'll go to visualization panel of the shared and suppressed edges and then check whether any free or non-manifold edges are there on my geometry or not. So as on the GUI you can see there are no free and suppressed edges. So my geometry is perfectly enclosed volume. Now I will go to 3D page. In 3D page I will go to tetra mesh panel to generate a 3D tetra mesh for my knuckle structure. So I will go to 3D tetra mesh. On the tetra mesh panel I will select the volume tetra radio button. This is the automation process for the tetra mesh. In the enclosed volume, select surfaces because you have surfaces. In my geometry I have surfaces, so I will select surfaces. If you have solid, you have to select solids. So I will select the surfaces. So if it's an enclosed volume, once I will click any one of the surface, it will pick all the surfaces because it's an enclosed volume. Then in the 2D type I will select R trias. R trias are used because they capture the curved regions more accurately. So we prefer mostly R trias. You can also do the tetra meshing using chord trias mixed also, but R trias are more preferable. Then select the 3D type as tetra because you want to generate a tetra mesh. So select the 3D type as tetra. Make sure the elements to current component is selected, toggle it down so that your current component on the mesh will be there in the current component. If it's not a current component, on the bottom you can see it will show you the current component. This one is the current. If your component is not current, you can make it current. If you go to the mouse here, you can see set current component option. This my component is current. If it's not, we can make it, just right click on it and make it as a current component. Then check the box for use curvature and use proximity. It will capture the sharp features, use curvature, so it will generate the good mesh pattern along the curved areas, and use proximity will help you to create or capture the sharp features like this, the sudden change in the surface or geometry. It will help you to capture those also. So now as you can see, I have ticked it. Then in the minimum element size, we can enter an minimum element size of 5 and average element size of 2. So it will create a dense mesh. And feature angle stands for the angles between the two elements normal. So lesser will be the feature angle, more dense will be your meshing around the curved regions. So then once you select all these parameters, click on mesh. Once you click on mesh, it will start generating the mesh for this structure. Now as you can see, my 3D meshing is done. So I will off this surfaces to view only the mesh, or you can say the elements. So in this way my 3D meshing is done. I will go to mesh panel and mask any one and just check. This is the 3D mesh. As you can see, if I on the surface and make it in the line mode, you can see it has completely filled my geometry with the elements. So these are the elements, the 3D elements. If I unmask all and pick any one, so this is the 3D element. This is the 3D tetra element. Okay. So again now I will off this geometry and will move to quality check. I will click return to exit the tetra mesh panel. To enter to quality check panel, we have two options. First is go to tools and click on check elements, or you can click F5 from your keyboard to enter to check elements panel. So I'll enter press F5 from my keyboard, sorry, F10 from my keyboard. You have to press F10 from your keyboard to enter check elements panel. For 3D elements, we generally check aspect ratio, that is the ratio of minimum length to maximum length, then tet collapse, minimum angle and maximum angle. This minimum angle is the minimum angle of tria face. So this is the tria face of a tetra element, and this angle is the minimum or maximum angle. So if your tetra element or face of the tetra element is something like that, so minimum angle is very less, so we can improve that also. So I'll put minimum angle value as 10, maximum angle can be 140. Aspect ratio should be 5, so we'll first check one by one. So I'll pick aspect ratio and show you how to solve these errors. And click on save failed, go to mask, elements, retrieve, reverse and mask. So by this only those elements on my GUI will be visible, those who are failing in aspect ratio. So I will create nodes on this, press shift F2 from my keyboard, drag the window and pick those nodes. So you can see these are the elements which are failing in aspect ratio. So as I already told you, aspect ratio means minimum to maximum length ratio. So for this particular element, we can see the minimum length is this one. So quickly I'll press F10 again and check what is the aspect ratio for it. It's 6.25, for this 7, for this 7. So I will go one by one by changing this distance. So to change the distance between two nodes, press F4 from your keyboard to enter the distance panel, or from geometry go to distance panel. Select the radio button as two nodes, pick the node 1, 2, and as you can see the distance between these two nodes is 0.02. so I will increase it to 0.3, and then again press F10 to check what is the aspect ratio now. So you can see my aspect ratio comes under 5 for this one element, for this element, and for this element. So all my elements are now passing for this region. So as there are many elements, so it's always better those to mask those elements which are being passed by you. So I will mask these elements. Also again I will press Shift F2 and clear these nodes. So I'll move to the next. Follow the same process. As you can see, this one is very less. So I will increase this distance. So I'll press F4 from my keyboard. So from this to this I will increase it to 0.1. Again from this to this I will increase it to 0.1. And then again press F10 from keyboard and check the aspect ratio. It's coming as 8 for this element, for again 8 for this, 6, 8, 5, 8 and 5. So I have to increase some more height of this length. So there are 2-3 options. Actually we have to decrease the aspect ratio to 5. As I already told you, aspect ratio is the ratio of maximum length to minimum length. So either you can decrease the maximum length or increase the minimum length to lower down the aspect ratio. So again I will change it to 0.1, or you can say 0.2. Here also I will change it to 0.2. From N1 to N2, only N2 nodes will move. The node in the blue color will only move. Then again I will press F10 from the keyboard and check. Now it has lowered down to 4.5, 4.5, 3.5, 4, 3, 4. So all these elements are passing. So I will mask this also. Press Shift F2 and remove these nodes. Don't click on clear all. If you click on clear all, it will clear all the nodes. But these nodes are important to check the elements. So don't click on clear all, just click on clear to clear those elements which are selected. Now for this one, again as you can see the distance is very less. So F4 from this point to this point, F10 check this, 5.4, 5.4 and 4. So I will again decrease it a bit. So go to F4 again from this to this. This time I will enter as 0.6 and check F10, 4.5, 4.5, 4.3. So now it has been done. So I will mask that again. Click on the mask icon, mask this, Shift F2 and clear the nodes. To clear the nodes, it will lower down your confusion. So now you can see only this one is left with. So this time I will decrease this one to 0.5 or say 0.55. Also I will increase the height of this. So I will translate this node to increase the height. So I will pick this node. To translate the nodes, you can press Shift F4 from your keyboard or go to Tools, Translate. There are two options to enter to translate panel. First is to press Shift plus F4 from your keyboard or go to Tools, Translate panel. So I will pick this node, define a plane by selecting 3 nodes, and on the perpendicular axis of this plane it will translate with a distance of 0.1. So now you can see I have translated this. Now again I will press F10 and check. It's 3 and it's 3. So now it's passed. So now I will again mask it and Shift F2 and clear these. So these two now left with. So you can see here also the distance is very less. So I will go to F4 from this to this. improve the height to 0.2. I think that will also work. From this to this, 0.2. From this end to this end, 0.2. Again press F10 from your keyboard and check. It's 5.6, 5.6, 4, 4, 5.2, 5.2, 4 and 4. So I'll just make it a little bit change, say 0.25. This one also 0.25, and also I will change this length because this is the maximum length I can see. So I will make it as 0.6 and 0.25. Then I'll check it as 4.5, 3, 4.5, 3, 4, 4.2 on the bottom. You can see aspect ratio 4 and 4.7. So all these are passing, so I will mask them. Shift F2 and click on clear. Now on the screen only these elements are failing, as you can see. So this is because of this height. So I will again improve this height. First check what are the aspect ratios. So it's 29, 29, 9, 21, 6, 9. So I will change it to 0.2. This one also as 0.2. Then press F10, 6, 4, 6, 5, 5 and 3. So I will just decrease this length. This will also help us to clear the Jacobian, aspect ratio. So it's coming as 6. So again I will improve the little bit height to say 0.2. Go to F10 again, 5.8, 5.8. I'll increase a little bit more height. So 0.25. Again F10, 4.6, 4.6, 3, 5.5, 5.5 and 3. So I will just improve this one height also. So this to this 0.25. So again if I go to F10, it's 4.8, 4.4. So now this is also passed. So I will mask, Shift F2 and clear. So if I press F from my keyboard, now I can see there are no elements which are failing in aspect ratio. So I will click on unmask all icon to unmask all the elements. Then again press F10 from the keyboard and click on aspect ratio. So now you can see only two elements are failing in aspect ratio having 5.01. So you can either take it because it's not a bad aspect ratio, it will pass the quality checks of the element. But if you want to improve that also, you can follow the same process. Click on aspect ratio, click on save field, go to mask, elements, retrieve, elements, reverse and mask. So those two elements which are failing in the aspect ratio will get highlighted. Press Shift F2 and create the nodes. Now you can see the nodes have been created. These two elements are failing in the aspect ratio. So F4 and just improve this height to 0.35 and check for the aspect ratio, it's lower down. So again click on unmask all. Go to Shift F2 and click on clear all to clear all the nodes. Again press F10 from the keyboard and click on aspect ratio. So you can see now all the elements are passing in the aspect ratio check. Then I'll move towards the next check, that is the TET collapse. The acceptable TET collapse value is 0.2. TET collapse stands for the height of the tetra element. So it's the ratio of actual height to the expected height. So TET collapse you can say as the height of the element. So if the height as per the Pythagoras theorem, because these are the tri-elements, are tri-elements, so it should have a proper height. So due to the Pythagoras theorem, if its height is very less, so we can improve the height. So we have to improve the height, because if the height is very less, it start behaving like 2D element, it will not be a 3D element. Okay, so first click on TET collapse and click on save field. Mask will follow the same process: elements, retrieve, reverse and mask. So then press shift F2, shift left mouse button and drag from end to end to select all the nodes or of the elements which are failing. So these are the elements. First one, this one is the element which is failing in TET collapse. So I will improve this height. First I need to check what is the TET collapse value of this. It's 1.179. So I will improve it by translating the node. So shift F4, pick this node and click on translate plus or negative. This defines on the plane. So it has increased to 0.269. I again go to mask this element. As once it's get passed, I will mask it. Then I will move towards this one. As you can see, these elements are failing due to the TET collapse. So its height is very less. So I will check where it exactly comes in the geometry, because if I want to increase the height, if I increase the height in the lower direction, so it may affect my other elements. Here I will show you. So I can increase the height in this direction, upward direction, because that will not affect the other elements. But if we increase the height in the lower direction, it may or may not affect the other elements. So we have to always check that whether these are failing in the elements or not. Or there is one more thing: if you can press shift F5 from your keyboard, go to find attach, select the find attach radio button, select those elements which are failing in TET collapse and click on find. So it will find the attach elements. So you can see these are the attach elements. So once you improve this, this may get distorted or may not. Or we have one more option to improve the quality of tetra mesh that I will show you. Go to 3D. In 3D, select tetra mesh panel again. This time select tetra remesh. Select the 3D elements. Free boundary faces, make it in 3D elements, select those elements and click on remesh. So once you click on remesh, there are chances that it may get passed. Again go to F10 and select TET collapse. So you can see still 13 elements are failing in TET collapse. So now I will highlight those. Click on TET collapse. Click on save field. Go to mask, elements, retrieve, reverse and mask of this geometry. So now you can see some of the elements get passed. Now I will again go to shift F2 and add some nodes here. And now I will try to improve the height of this particular element. So go to shift F4, pick these nodes, define a plane, and translate that node. We can also translate this one. So we'll select this node and the plane can be this. Will marginally translate it. Now I'll go to F10 and check the TET collapse for this. This one is passing. This is also get passed. So if you click on TET collapse, only these many elements are getting passed. Some are getting failed. So now we will try to make them pass also. So I can increase this height of this particular element. So I will first create a node between, and with reference to this node I will increase its height. Similarly for this I'll go to F4 to create a node. From this point to this point I will create a node, and from this to this I will increase its height. So again I will go to F10 and click on TET collapse. So now you can see most of the elements are passing, but few are now failing also. Then I will decrease this height to 1. Press F10, TET collapse. It is coming as 0.172. Then I'll pick again unmask all, shift F2 and clear. Now I will check how many elements are failing now. So 5 elements are failing in TET collapse, as you can see. So again click on save failed, mask, elements, retrieve, reverse and mask. Shift F2, add the nodes. So these are the elements which are failing in TET collapse. So we will increase the height of these elements. So first of all I will make this to 0.2, I can say, or 0.3. Create a node in between these two and then change the height to 0.1 and then check the TET collapse value. It's coming as 1.8, 1.13. So F4 from this point to this point, I will decrease a little bit height, so to 0.85. Then F10, it has got passed. This one is still failing. So again shift F4, I will translate this node along this plane. F10, 0.19. A little more. Again this node, defining a plane, shift F4 is used to translate. F10. Now you can see this one is passing. Similarly I will try to improve this height. So F4, first I will decrease this Pythagoras line, so to 0.25, and then from this node to this node 0.1. F10, if I check, it's passing. So in this way you can improve the height of the tetra element. For this particular element I can use shift F4, define a plane and translate. F10, it's got passed. Then similarly for this one, so this one height is very big, this length is very big, so I can reduce that length, so it may pass the TET collapse value. So 0.85 will be sufficient, as you can see. Now I will check for this, it's 1.5. So again shift F4, this node will translate a little bit with this plane. F10, and you can see it's 0.199. Again shift F4, this node, define a plane. F10, it's passed. Click on unmask all. Shift F2, clear all the nodes, temporary nodes. Again click on aspect ratio first. Now it's passing. Tet collapse. Only one element is failing, with having the tet collapse value as 0.17. So I'll show you how to remove that also. So again click on tet collapse, save failed, mask, elements, retrieve. It will retrieve one element, reverse, and mask. Shift F2, add that. So this one is the element which is getting failed. So we will improve its height. Shift F4. First we'll check how much it's coming. It's 0.168. So shift F4. This node, defining a plane. F10. It's passing. So now you can see all my elements are getting passed. So again shift F2 and clear all the temporary nodes which I have created. So tet collapse, aspect ratio is passing. Tet collapse, one element is failing with 0.19. It is okay to have a 0.19, but we will also try to remove that. So again tet collapse, save failed, mask, elements retrieve, reverse, and mask. Shift F2, add the nodes and translate the middle node to improve its height. Shift F2, clear all. Again press F10 from the keyboard. Aspect ratio is passing. Tet collapse, all the elements are passing. One is having somewhere around 1.1 something, so that also we can improve. So again tet collapse, save failed, mask, elements retrieve, reverse, mask. Shift plus F2, add, press F from the keyboard to view that particular element. F4, I can decrease this distance to 0.58 and check its tet collapse value. It's very less. Then shift F4. First I will find what are the elements through which it is connected. So shift F4, if I increase this height, a little bit, then what is the tet collapse value? So unmask all, shift F2, clear all. Again go to F10, check elements. So now my elements are getting passed. Then we will check for the minimum angle. So all my elements are passing the minimum angle criteria and also maximum angle criteria. So Jacobian will be perfect for this. As you can see, it's 1. So all my elements are passing to all the elements qualities. So my meshing is ready to perform the analysis. So once my meshing is done, I will follow the same process as MPCLL. So first I will create material. As steel. Select the type as isotropic. Card image as mat1. Click on create edit. Enter the values of E, new and row. Click return to exit this panel. Then the next step is to have the property MP. P stands for property collector. So I will go to property icon, property collector icon. Enter the property collector name as knuckle. Define a appropriate color for it. Select the type as 3D because I am using the 3D elements. So I'll select property types for 3D. Card image as P solid. I will pick the material. Click on create edit. So you can see in the 3D we don't have to provide any other parameters related to the other dimensions for the 3D element. So we'll click return. So on the model browser you can see my material and property is created. Now my next step is to have component updated. So here you can see the next step is component collector. So I will click on component icon. As I already have a component, so I will update this component with proper property and material. So I will go to update panel to update the component. Click on comps, select the component in which my elements are there. So if you click on this icon, you can check on which component the elements are there. If you have 5, 6, 7, 8, how many so many components are there. So first check on which component your meshing is there. So on, off. If due to this the meshing is getting on and off, so on this particular component your elements or meshing is there. So you have to update that. From the no property, toggle it to property and click on the property. Select knuckle property and click on update. So this will update the component collector as well. You can check it by element color mode. So this is the mode for component color. So you can see the component color is visible on my elements. Then the property. So you can see the property color you can see on the elements. And if you select by matte stands for material. So you can see the material collector is there. So if you change the color, it is changing on the elements also. So my elements are assigned with proper property and material. So I'll move ahead with the next step to define load collectors for torque, force and constraint. So as I already told you, I'm going to apply the forces in X and Y axis on this inside region having a force of 3G and a Z axis force of 1G plus some torque in opposite direction. One is in Z direction of 0.5 G and one is in negative Z direction, another one is in positive Z direction of 1 G, combining both. So 0.5 G in this end, 0.5 G in this one. And we'll apply the constraint in all these bolting locations, that is this one, this one, this one, and also these I'm going to constraint. So now you can see, to apply force, there are two ways in hypermesh. First, you have to, as I'm going to apply the force in the inner circle or inner portion of this knuckle part. So either I have to count all the nodes and then divide the total force by the number of nodes and apply the force on each node so that the total amount of force get applied properly. Or you can create a rigid elements and apply the force at the center of the rigid elements, so it will get equally distributed to each and every node. So I will show you the second option, which is more simpler and appropriate and easy to update for the further process. So I'll show you that. So what I will do to create the rigids, first I want to have a center node of this cylindrical portion. For all these, I will first create a center node, and with that center node I will connect all these inner nodes through a rigid element. Rigid element help us to transfer the forces and constraints with equal amount on each and every node. So you can easily update that also, or it's easy to apply also. So what does a rigid element, how it creates? So it creates some rigid nodes like this. It creates a spider something like this. So I will apply the force in this axis and it will transfer the equal amount of force. It will calculate how many rigids are connected through this node and it will divide all these rigid by total amount of force and transfer the force. So if you have 50 rigids connected with the center node and if you have applied 500 Newton of force, so on each node it will automatically transfer 10 Newton. Whatsoever the distance from this to this, if bigger or smaller, if it's transferring the force of 10 Newton on this, it will also transfer the 10 Newton on this. So it will be easy to have the rigids connection and update on apply forces on rigids and update them also. So I will show you the process to create the rigid elements. So before that I want to have a center node of this cylinder. So to create the center node I will again go to distance panel, but this time I will select 3 nodes and select these nodes, select arbitrary any 3 nodes on the circumference of this circle and click on circle center. Again I will pick any 3 arbitrary nodes along the another circle, another circular portion of this cylinder and click on circle center. Then the nodes between these two circle center will be the center of this cylinder. So I will pick node 1, node 2, N1 and N2. Make sure you select N1, N2 and click on node between. So it will create a nodes in between these two. So this node will be the center of this particular cylinder. I will repeat the same process for the rest. So make this circle center, make this one circle center, pick N1 and N2 and click on nodes between. So it will create a node between here. Similarly for this one, deselect it, select N1, N2, N3, click on circle center. Similarly select N1, N2, N3, again circle center, N1 and N2 and nodes between. Then on this side, deselect it first, click N1, N2, N3, circle center, then again N1, N2, N3, circle center, this to this nodes and node between. Similarly deselect it again, N1, N2, N3, circle center, N1, select any arbitrary 3 nodes, circle center, pick N1, N2 and node between. Then for this, circle center, circle center, deselect it, make sure it's N1 and N2. Then this one, circle center, again N1, N2, N3, circle center, then deselect it, make sure this is N1 and N2 and nodes between. So in this way you can see all the circle centers have been created, but there are some nodes at the circumference also, so that may cause a confusion. So what I will do, I will remove those nodes. So go to Shift F2, select these nodes one by one, There are chances of getting error in this point by mistake selecting any nodes arbitrary. So it's always better if you have created circle center. So just save this file. Click on save as and save this file. So if you have any issues, you have this file. So you can open that also. So shift F2, pick these nodes. And click on clear. So now I have got only the circle centers. I will again on the meshing, so you can see 1, 2, 3, 4, 5, 6 and 7 cylindrical centers I have received. Now by getting the help of these centers, I will create the rigid elements. So rigid, as I already told, we are going to create rigids. So rigids are also elements. So we have, but we don't have any property. It is not required to define them a property or material, because they are only used for the load transfer as the connecting elements. So it is not required to have the material and property for that, but we have to define one component for them, because the meshing should go in the definite component. If we create the mesh rigid elements in this component, so the property and material of this component will automatically assign to that rigid elements, and it may have it will create some errors during the solving. So first of all, I will create one component. Go to component icon. Make sure you have selected create radio button. Enter the component name as rigids. Select a proper color for it. Toggle it down to no property and click on create. So it will create a rigid component collector. And now I will create rigid elements and define them in this particular component. So to define or to create rigid elements, go to 1D. In 1D, you will find rigid elements panel. So select rigids. Make sure all the degrees of freedom are checked. Select the element type as RBE2, that is rigid element 2. Select the independent node as the center node and dependent node as the any other node on this inner circumference. Similarly from this to this. But the problem will remain the same, that if you want to apply the one by one nodes, so the problem will remain the same, that it is also very tough to create one by one rigids on this. So what I'll do, I'll show you one more option. So I will delete these rigid elements. Then select the independent node as the center node, and in dependent select multiple nodes. Click on any one node on the circumference, inner circumference. Then again click on nodes and say by face. So it will pick all the nodes on this inner face and click on create. So at a one shot it will create the rigid connection. I will again show you this process. Select the independent node. Select dependent node to multiple nodes. Select any one node on the circumference. Click on nodes, say by face and click on create. So it will automatically select all the nodes and create the rigid elements. Similarly, independent as the center. For dependent, select multiple nodes, click on any one node on the inner surface, nodes by face, create. Independent as the center, pick the node, nodes by face, create. This node, nodes by face, create. Nodes by face, create. And for this, nodes by face, create. So in this way I have created all the rigid nodes, rigid elements at all on all the circular portions. Now I will apply the constraint and force on the center node, so it will get transmitted in equal amount to all the areas or on all the nodes. Okay, so I'll again on the meshing. So now I will start applying the forces, constraints. So I'll start with constraint. You can start with any one, either constraint, force or torque. That's not the issue. So I will start with the constraint. So to create constraint, first I need to create a load collector for constraint. So I will create a load collector as SPC, giving a proper color with no card image. Click on create. So a load collector as SPC has been created. As I already told you, I am going to apply the constraint in this 1, 2, 3 and 4 bolting locations. So I'll go to analysis to apply constraints. Go to analysis, constraints. Select these nodes, all the center nodes of this rigid elements. You can off this rigid and check whether you have selected it or not, and only will constrain it to degrees of freedom 1, 2, 3, because solid element does not support degrees of freedom 4, 5, 6, that is rotation about XYZ axis. Solid element only support degrees of freedom for the translational degrees of freedom, that is translation along XYZ. So I have selected all these and then click on create. So if I on this load collector, you can see, and on the rigid you can see my constraint has been applied at the center, so it will get transmitted to all the inner surfaces, inner nodes of the surface. Now my next step is to apply the torque. So generally to apply torque, what people used to do is they use, if the unit of the torque, as you all know that it's Newton per mm. So what they do, how much torque they want on this portion, they create that much amount of distance from this particular point and apply that force in downward or any particular axis to get a torque in this particular zone. But in hypermesh, we have a dedicated panel through which you can directly apply the torque on this particular node. So I'm going to apply the torque in Z axis for this particular model. So I'll show you how to apply the torque on this model. So first, to apply the torque, I need to have a torque as the load collector. So I will apply torque, define a proper color for it. So on the model browser you can see my torque as the load collector has got created. Then to apply the torque, you can go to analysis, movements. So click on movements panel. Once you enter to movements panel, select Z axis as the axis of the torque. I am going to apply a torque on the Z axis, so it will allow this to rotate in XY plane. So I am considering the torque to be around 1G. It's an assumption, so you can select as per your component what torque you want to apply. So this time I am applying the torque as 1G. So 1G stands for, if I am considering the weight to be 400 kg, so for one wheel it will come around as 100 kg for the sharing point of view if I consider. So it will go around 1000. So I will apply a torque of 1000 and say create. I will pick the node on which I want to apply the torque and say create. So now you can see I have applied the torque in this. Similarly, I will apply the torque on the top and say create. So in this way I have applied the torque. For these two you can apply the opposite torques. If you want to apply the opposite torque, just enter the value as -1000 and say create. If I increase the value, so you can see this is the opposite torque. So this will try to move in clockwise direction, or this will try to move in anti-clockwise direction. Now my next step is to apply the forces in x axis of loading as somewhere around 3G. So I'll go to load collector and define a force as force x, define a color, then click on create. So my force x will get created. Similarly, I will create a new force as y and z. I will create all the three forces, and then after then I will apply it on my model. So now one by one I have created all the three load collectors for three forces, that is force x, y and z, and now one by one I will apply them separately. So to apply them on my model, go to analysis, forces, select the node on which you want to apply the force. So as you can see, my current, the bold one is the current one, so my current load collector is Z. So first I will apply the force in Z axis. Here also I am going to consider 1G force, so I will select 1000 and click on create. So you can see it's selected 1G force. Then I will select force at x axis and make it as make current. So I will make current, make sure the load collector force x is current. For this I am going to apply a 3G. So I will enter here as 3000 in x axis, and again I will pick the node on which I want to create a force. So it has created a 3G force. Similarly in y axis I will make sure it is make current, pick this node and say create. So in this way I have applied the forces, constraint and torque. So I will off this meshing and check whether everything is perfectly fine or not. So I'll also off these nodes. So now in y axis it is showing blue color, that means it is perfectly in the load collector of y axis. Yellow color shows the torque, that means it is properly in the torque load collector. Red color represents SPC, so triangles are SPC, it is properly in color. The x-axis and this color is same, so I will change the x-axis color so you can see it's perfectly okay. Pink color represents the force in Z, so the force is applied in the Z direction is in force Z collector, and values are also perfect. For y-axis it's 3000, x-axis also it's 3000. For movement it is 1000 in opposite directions, and for force it is Z direction, it's 1000, and we have applied the constraint in 1, 2, 3. So in this way I have done with the loading conditions. But for the knuckle, sometimes you need to apply the forces and the combination. Say for one case your x and torque will act simultaneously. In one case your y or torque, y direction force and torque may act simultaneously, or in some cases your z direction and torque may act simultaneously. So now I will show you how to simulate combined loading, how to apply combined loading in hypermesh. That I will show you if there are some forces acting simultaneously on your model, or there may be some cases where all the forces will act simultaneously, or the combination of 2 or 3 will act simultaneously. So I will create some more load collectors for the combined loading. So firstly I will note it down what are the combined loading I am going to simulate. So first combined loading will be x force and torque. First one is x force and torque. Second one is y force torque. Third one is z force and torque. Fourth one is X, Y, Z and torque, everything is there. Fifth one will be, say, suppose X, Z and torque. If you want to simulate some cases like this, or you can say YZ torque, that also you can simulate. So you have to decide what type of loading conditions you want to apply. Accordingly, if you come up with like if I am going to apply the combined loading, then what are the combined forces your knuckle will have. So accordingly you can apply the combined loading on it. So I will show you how to apply the combined loading. So first I will create a load collector for X and T. So I will click return. Go to again load collector panel. This time I will enter the load collector name as combine X T. Enter from no card image to card image. Click on the card image and click on load card image. This will help me to combine two or more loading conditions or load collectors and apply it at the same time. Then click on create edit. How many loads you want to create, you can enter it here. As for the first case, I am going to combine two loads, that is X and torque. So I will enter the load number set as 2. S stands for the scale factor. So if you want to magnify that particular loading condition, you can magnify it through the scale factor. This S11 stands for the scale factor for particular loading, and this one is for the second loading. So whatever you select for the first loading, as I am selecting force X, so if you enter 2, it will multiply force X with 2. So whatever the force you have applied in force X, it will multiply that value with 2. So as I have applied 3000, so it will multiply it 6 and then apply for the combined loading. So I don't want that. So I will pick it 1, and torque also 1. So X and torque I have applied 2 and 3. Similarly, I will create one more for Y, T, and click on create edit. Again 2, S1 as 1, this one also 1. So this one is Y, torque as 2. Then ZT, create edit. Again 2, 1, 1. Z, torque. Then I have taken as XYT. So here I will enter as XY, create edit. For X, Y, Z and T, I am going to apply combine 4 loads. So I will enter here as 4. S1 1, 2 1, 3 1, 4 1. For load 1, torque, force X, force Y, force Z. So in this way I am going to combine 4 loadings, that is 2 3 4 5. So I have selected 2 3 4 5. This number represents the number of the load collector. From this you can cross check, that is 2 stands for torque, 3 stands for force X, 4 stands for torque Y, force Y, and 5 stands for force Z. Similarly, if you want to have some combined loading as X and T, create edit. Enter value as 3, 1, 1, 1, torque, X, Y, or you can apply as X, Z, T. So create edit, 3, 1, 1, 1, torque, X, Z. In the same way you can apply any combined loading. The process will be same, but it will depend on your model. What are the combined loading you want to simulate for this roll cage structure. Now I will simulate all these conditions separately with by creating separate load collectors for it. So in the one file I can simulate different load collectors, that is what will be the stress and displacement due to combination of force X and T, what will be the displacement and stress value due to the combined loading of Y and T, Then Z and T, combined loading of due to Z and T, the stresses and displacement. What will be the stresses and displacement due to combined loading of X, Y and T? What will be the combined loading due to the combination of X, Y and T? What will the displacement and stress? Similarly, the value of displacement and stress for the combined loading in for the X, Z and T. So to define the load collectors, I will go to analysis, load step. So first I will create some different load collectors. First, if only force X is applying on my model, then what will be the stress and displacement? So I will create force X, check the box for SPC and load. So SPC for SPC, loads as force X, click create. So my first load collector has got created. Then for the force Y, SPC will be SPC, force Y, create. Then for Z, SPC will be SPC, loads will be force Z, create. Then if only torque is applying on my model, so SPC plus torque, create. Similarly, if combined loading of X and T is there, then SPC will be SPC, load will be combine XT. This time give the value of load collector as combine XT, click on create. Then the next will be YT, check the box for SPC and select SPC, YT, create. Similarly for ZT, SPC, load as ZT, create. Then X, Y, Z and T, so SPC will be same, load will be X, Y, Z, T, create. Then the next will be X, Y, T, so SPC will be same, load will be X, Y, T, create. And XZT you can also simulate as I have created the load collector. So I will select SPC as SPC, load as XZT and say create. So in this way I have defined 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 load steps for this. So in the results I can simulate these 10 different analysis results in one single file. So that I will show you what are the 10 different values of stress and displacement due to different loadings condition for this knuckle. So to run this file, first I need to save it. So I will save it as in a different folder. So I'll click on save. So in this way my file is saved. Now I will click on analysis and radius. Export option to all, run option to analysis, memory option to default, save the FEM file and click on radius to start the solver. So once you see the message as analysis completed, then click on results to view these results in hyperview. So click on these results. It will open a different GUI as hyperview, which will help us to view the displacement and stress plots for my structure. So this is my model. So one by one I will see what are the stress and displacement values due to different types of loading conditions. You can see here it has loaded all the 10 subcase 1, 2, 3, 4, 5, 6. If you scroll down to 7, 8, 9, 10. So first click on contour to view the displacement or stress plot. So select the result type as displacement and say apply. So this is the displacement plot. And if you select the result type from the drop box, element 2D 3D stresses, one mices, averaging method to simple, and say apply. So this is the forces, or this is the value of stresses due to force X. If you click on measures, you can find the maximum value of it. So the maximum value of the force is coming as 30 Newton per mm square in this particular node 9155. Okay, so if you change it to subcase 2, you can see for force due to X, the value is coming as 23.26 Newton per mm. You can also see the animation plot. You can click on this play button, decrease the time. As the displacement is very less, so deformation is also very less. So I will just magnify the deformation. So for the first load case, as you can see, the force is in X direction, so deformation will be like this. If the force is in Y direction, the deformation will be like this. If the force is in Z direction, the deformation is like this, and the stress value is 7.42. For fourth load case, when the combined loading is there, that is only the torque is there. If I improve this to a bit more, the stresses are coming very less. So you can see due to torque, it is behaving something like this. But the value of torque is very less, that's why deformation is very less. For fifth, I'll lower it down. For fifth, when X and torque is applied at the same time. Then for the sixth, when Y and torque is applied at the same. Z and torque, both the three, X, Y and Z and torque. Then X, Y and T, that is torque. Then the last case is X, Z and T. So you can simulate these 10 different load cases in a single file by the combined loading. So you can find out which one is the dominating force and where is the maximum stresses are coming. So as you can see, during maximum forces, either this or this location or in this location, the maximum forces are coming. So in this way you can find it out. But as the forces are very less, all these under the use sector of 50. So my component is quite safe, I can say that. So in this way, actually this process explained, this video explain you how to do the 3D meshing, how to improve the mesh quality, and how you can use the combined loading. So you can follow the same process to apply the different loading conditions as per your requirements. So you can use that, but the process will be same. Go to MPCLL, create load collectors, define rigids, and then apply forces, and then perform the different loading conditions. You can use the load card to combine them and apply the different loads at the same time. So in this way I have ended this video.